In our last example, we were looking at points and deciding if it was going to create a function, and we found out that if we have the same x, it's not going to be a function. So if you picture plotting points with the same x, just randomly picking some points, let's say 2, 5, you go right 2, up 5, and you've got your point, and then another one that starts with 2, let's say 2, 1, right 2, up 1. 2, 5 and 2, 1, they're stacked on top of each other. So another way to decide if something's a function, if you're not just looking at a bunch of points, is to see if there are any points that are stacked vertically. And so what we're going to use is the vertical line test. So if I use the vertical line test, as I move across from left to right here, notice that I end up being in contact with this circle in 2 points at the same time. So and that happens multiple places, because these points are stacked, it means they have the same x coordinate. So every x doesn't have a unique y, so this one's no. This kind of sideways V looking thing, as I go from left to right with my vertical line, I'm touching the graph in 2 spots at the same time, so not a function. This one here, it looks like, looks maybe a little interesting, a little complicated, but really, remember, open dots is a lack of a point being there. So when I move this from left to right, I'm in contact with the graph at this first closed dot. I'm in contact all the way through. I'm in contact at the end. But this closed dot lining up with an open dot, I've removed the point there. So at this spot, I have this point I'm touching, but that point I'm not. So I'm okay. Now, if those were both closed, then we'd have a problem. So we're only touching the graph with 1 point at a time. So yes, this one's a function. In this one, I've got several issues here. When I get to these 2 points, notice they're stacked. I'm touching the graph at 2 spots at the same time. Same thing right here. So no, not a function. When you have a line, you know, it's made up of an infinite number of points. We just don't highlight them all. But every single point is a little bit further to the right and up, to the right and up, to the right and up. So as I move this across from left to right, I'm only touching the graph at 1 point at a time. So that's a yes. These kind of random points here, I'm only touching 1 point at a time as I move across. So that one's fine. This sine curve here, the dot, next dot is higher and to the right, a little higher to the right, a little higher to the right, a little lower to the right, a little lower to the right. As I go across here, I'm only in contact with the graph at 1 point at a time. So yes, it's a function. And then this guy here, this upside down parabola, every point is a little bit further to the right and up, to the right and up, to the right and up, and then to the right and down, to the right and down. I don't have any points stacked. I'm only touching the graph at 1 point at a time, so yes. And then this last one here, I'm okay at the beginning. I'm okay at the open dot, because the open dot with a line. But as soon as I move past that open dot, I'm touching the graph in 2 spots at the same time. So this one is not a function. Functions are something that you use anytime you go to the store. Think about if I took this calculator and I put it underneath the scanner at the store, and I put it in the scanner, so it'd be calculator, comma, and then $10. And then I go, oh, how much was that again? I put the calculator under the same scanner there, and it says $15. Calculator, comma, $10, calculator, comma, $15. Something's wrong with this scanner, it's broken. You're right, it's not a function. But the dollar store is a perfect example of why you can have the same y's. I put this under, dollar. I put this under, dollar. I put this under, dollar. So calculator, comma, 1, pen, comma, 1, any item, comma, 1. All the y coordinates are the same, and yes, that's okay, that's a function.